In this video, we will explore the possibility of dynamically building the geometry in the DOP network. This has a really huge benefit compared to building the geometry in the sub-level, because usually let's see an example. I build a line here, and then I simply put it into the vellum and set it as string, and then we can simulate this string just like a usual normal string, nothing really special. But the problem is, what if I wanted the string to be infinite long? I can prepare an infinite long geometry and then put them all into the .NET, and also building the vellum constraints. So another benefit of building the geometry inside the .NET is, inside the .NET I have all kinds of the information I have. For example, I can have the force, I also have the information of the mass, the velocity, and all kinds of information. You see, we have velocity here. So based on this information, we can say remove some geometry or added some geometry. And that is the benefit of building the geometry inside the .NET, rather than preparing the whole geometry first. So what we are trying to do is this example. You see, the geometry seems to be spawned out of nowhere, because we are dynamically building the geometry each frame in the DOP network. So in this example, we will build a rope like this. So let's see, how do we do that? At each frame, what we are going to do is, in this example, is simply we will use a, let's see, closely. Let's see, kind of hard to find the correct. Wait a moment. Needed to. Alright. You can see that first we just add a point here, and then in the point wrangle we modify the position of the point. Each frame is like moving around in a circle, just a circle of parametric function, and then we jitter it a little bit. So basically we are trying to keep moving the points in a circle way, and then we build the string constraints out of this point, and we have the geometry and the constraints. And then in the .NET we will try to, at each frame we will fetch this point and trying to build the constraint geometry and the geometry inside the .NET. So let's jump inside the .NET. In the .NET, this is just basic vellum simulation setup. We have a ground static solver with gravity, and we use vellum object to create a vellum object with vellum solver. But for the vellum object, basically it's just an empty holder, because we will try to sourcing the geometry in the post-solve stage. So we can ignore this. And in the post-solve, we see here we use the geometry wrangle. First we create a polyline if we don't have any primitive inside the geometry. So basically we just first create a polyline out of it. So basically first we create a primitive, just a line, a polyline if we haven't have any, and then at each stage we are going to run the vellum source to, and using the subpath to sourcing the points from here. So at each frame we just have one point sourcing into the vellum. We set the activation to 1 for each frame, And for the constraint sub, we set it to the constraint point 2. So this is the vellum source, nothing special. And we are going to use a pop wrangle and set the bindings to geometry so it will run on the geometry. And for each frame, the newly added source geometry will be added to a group called new parts. This is an internal group set by vellum. So we will exploit this group to run in the newly added geometry, new parts. And then we just simply add vertex into our primitive. So at each frame, we added a new point. You can see, let's say we have 100 points now, and next frame we have 101 point. And we have another new point. So basically we keep building our geometry in this pop wrangle. But what we also have to do is that we have to build the constraints too. So we use the geometry wrangle, and the data binding should be bind to the constraint geometry. And let's set the input correctly. And for each frame, we simply build the constraint geometry by ourselves. And these attributes, primitive attributes, are required by the string, develop string constraint attributes. We can see it easily by creating a line, maybe some points, and use vellum string. That's vellum constraints, and then we build string constraints out of it, and we can see from the vellum constraint results that in the primitives it has these attributes: stress length, origin, stiffness, type, and damping ratio. So what we are trying to do is just to build the constraints like the constraints built by this node. So basically we are trying to recreate the constraints by adding a new point and a new primitive. And we also have to build the constraints for the angle preserving, because when we are building the string constraints, there's also a bend constraints besides stretch constraints. So we have two constraints to build. You can see we have an angle constraint and a distance constraint. So we are building two types of constraints here: the angle and the distance. So after we have built the constraints, we can just dynamically edit the new geometry and the constraints. So this is how it works in real time. This is the geometry. With this method, we have some additional benefits. Just as I said before, I can, let's say, maybe I can detect the velocity or something else in the .NET and deciding whether I wanted to create new constraints, new geometry inside the .NET. That's basically it. And the result will be like this. Interesting.